Welcome back. Today we're going to look at section 2.5. You will need a graphing calculator for this. If you do not own one, look at your Rapid Identity on your Chromebook. There should be a TI-84 graphing calculator option on there. For our topic today, we're looking at using linear models. Our goal is to be able to write linear equations that model real-world data and to use those to make predictions from our linear models. So the first term we need to understand is scatter plot. A scatter plot is a graph that relates two sets of data by plotting the data as ordered pairs. So we've got 5 different pictures here of scatter plots. The term correlation refers to the strength of the relationship between the data sets. The closer the points fall along a line, the stronger the correlation between the two variables. So our first picture we would refer to as a strong negative correlation because the points are very close to being in a straight line, and that line would have a negative slope. Our second picture is a little weaker. It still is negative in that it is going in a negative direction. It has a negative slope to the line, but the dots are a little further away from that line, a little more spread out. The third picture represents no correlation. We really can't visualize where we would draw a line through those because we can't tell, would it be a negative sloping line? There's just too much variation in the dots to be able to picture a good line. Moving on to the next picture, we see that the points now are moving upward as we go from left to right. So we're looking at now a positive correlation. It's still a little weak because the points are not exactly on that line. But in our last picture here, you'll see that the points get closer and closer to forming a line, so the correlation gets stronger. The table lists average monthly temperatures and electricity costs for a Texas home in 2008. The table displays the values rounded to the nearest whole number. It says to make a scatter plot, and then how would we describe the correlation? We are going to do this on our calculator, so go ahead and grab your graphing calculators. All right, so here's my graphing calculator. The first thing I want you to do, we want to check to see if you have something called the Diagnostics turned on. So let's go through and do second and then the 0 key. We're going to go to our catalog. And now you're going to use your arrow key and scroll down. We're looking for Diagnostics on. All right, so we want that one, Diagnostics on. We're going to hit Enter. Now, notice it still has a blinking cursor there. We have to hit Enter again, and then it will say Done. If they have turned the Diagnostics on, that will be important as we move through our process today. So the first thing we want to do to make a scatter plot is we want to press our Stat key, and we're going to choose Edit. All right, then we're going to put all of the X values into list 1 and the Y values into list 2. And then we're going to actually create the stat plot. So these first 2 steps are really just getting all the data into the calculator. So notice that our chart here, we have average temperatures in those first columns from January through December. So all of those values are going to go into our list 1. So this will be my first entry, second, third, fourth, etc. And then I'll move to July and get these added in. Okay? So I'm going to try to move this over so we can still see it. All right, so on our graphing calculator, we are going to our Stat key. It is right here near our arrow keys. We want to choose Edit, and since it's already highlighted, I'm just going to hit Enter. And now notice that I already have some data in here. It's the wrong data. It's from a previous question I was working on. So I wanted to go over how do we clear all of that data out. It is important that you don't delete because you will be deleting the column. You want to just clear the data. To do that, we want to arrow up to where it has the list name. This is called list 2. And we want to hit the clear key, which is right here underneath our arrow keys. We want to hit clear and then hit the enter key. And it's going to clear out that data. Okay, now I'm going to move up again, this time over to list 1. Again, I'm going to hit the clear key. And when I arrow down or just hit enter, it's going to clear that list. Okay. Now what I want to do is I want to enter all of those temperature values into my list 1. Okay, my list 1 is like my X values in a T-chart. So my first number is 61. I'm going to type that. You'll see it show up right down here. And then I'm going to hit enter and it'll go into my list. Okay, my second number is a 58. Enter. 57, 75, 79, 83. Moving over to July, we're at 84, 85, 81, 76, 65, and 58. Okay, so we have our 12 values in. Now we're going to arrow over and it'll pop me back up to the top of that list. And now I want to enter all of my electricity bills. So these are going to be in my list 2, all of my electricity bills. All right. So my first one is 150, 139, 172, 205, 170, 234, 255, 245, 210, 183, 132, and 110. All right. Notice that my X's and my Y's, list 1 and list 2, have the same number of values paired up. If you get an error message that says dim mismatch, like dimension mismatch, it means that you don't have the values paired up. You have one column that has more numbers than another. Okay, so we've entered our data. Now what we want to do is create a stat plot of that data, a scatter plot. To do that, we're going to go to our y equals key. And notice up on the top where it says plot 1, that's what we want to create. Okay, so plot 1 needs to be highlighted. Let's actually, let me back up here. Let's go second y equals. Let's actually go into our stat plot. And I'm going to choose the first option. It's highlighted already, so I can just hit enter or I can type the number 1. And now I'm into that first plot 1. And notice that plot 1 is highlighted in black. I do want to turn it on, so I'm going to hit enter to turn that on. I have the type already set as the first one. That's the scatter plot. And then notice that my X's are in list 1 and my Y's are in list 2. When we were in that stat edit feature, we did have up to 6 lists. Typically, I just keep those using list 1 for X and list 2 for Y. The second thing down here, the mark, I like to use the little squares or the plus sign. The dots get kind of small if you have a lot of data. It's a little harder to see it. All right. The next thing we want to do, we've done second y equals. We've created the criteria for our stat plot. Now what we do is we have to turn it on. Okay. So we're going to go to our graph. And typically our graph is set up from a -10 to a 10 window in both directions. And that doesn't always fit our data. If you think about the Y values that we were typing in, they were in the 100s. So this isn't showing anything because we're not looking in the right spot. If we do a zoom 9, it's going to change that window for us and adjust it so that we can see our dots. Okay, that's a zoom fit. Your other option would be to go in and recreate the window. If you want to do it by hand, this is now the window that it is zoomed in for me. I could have gone in and created a separate window. Maybe I want my X's. What was my highest X value? 83, 85. So I could have my X's go from 0 to say 100. And my Y values, we'll take the tick marks out. My Y values could go, what's my highest Y value? It was 255. So let's go from 0 to maybe 300. And again, I'm going to just take the tick marks out. We don't need the X scale and Y scale. If I do that and hit graph, now I still have my origin showing up. So I have kind of a point of reference. All right, so you can either set the window by hand like that, or you can just do a zoom 9 and it will fit the window to the data you see. The only problem with that is you do lose that origin point. So you're not seeing your X and Y axes anymore. All right, so based on our picture here, we would describe this as a positive correlation. My dots appear to be moving upward. Okay. They're fairly close to that line. And what we want to do now, let me go back to my notes page here. We would say based on that, we have a pretty strong positive correlation. Okay, we can kind of visualize a positive sloping line going through those. So our next step is to actually figure out what is that line. It's called the line of best fit. It's a line that best approximates the relationship between the variables or data sets of a scatter plot. This line can be used to make predictions. Okay, so it's our best approximation for our data. And again, we're going to use it to make some predictions. To get that line of best fit on our calculator, we have 3 steps. We're going to go into our stat key. That's the same place we went to edit and put our numbers into our lists. But then we're going to move over to the calc option and choose number 4. It's called a linear regression. So when we find a line of best fit, we're looking for that linear regression. All right, let's go back to our calculator. Our first step is to go to stat. We're going to move over to our calc option. So use your right arrow to move over to calc. And then look at number 4. It says linear regression. You can either type the number 4 or you can use your arrow keys and move down to 4 and hit enter. It's now asking us to identify where we put our X and Y values, and we used our list 1 for our X's, and we had our Y values in list 2, so this is set up fine. If we want the graph to show up automatically, we can go to this store regression equation. If you want to type the equation in by hand, you can skip this and go right to calculate. Okay? If we wanted to store it, our steps are going to be to do the variable key. So we're going to choose this vars key. It's right next to our clear option. We're going to arrow over to Y variables. And then we're going to choose the first option, function, and we're going to choose Y1. Okay? And so now you'll notice that it's telling us that once it calculates this best fitting line, it's going to actually put it into our calculator for us so we can graph it. Then we're going to move down to calculate and hit enter. Now, notice in this window, the format they've given us, y equals ax plus b, kind of like our y equals mx plus b format. They're giving me an A value of 3.615 and a B value of negative 75.9. Let's check that because that seems different than what I had before. 1 second. Okay, I did go back and look at my list. I do have one error here. I was trying to read from a very blurry picture. This 57 is supposed to be a 67. So let's change that to 67. And let's redo this now. So we're going to go to our stat again, over to calc. We're going to choose option 4. Again, we're going to store it by doing variables, arrow over to Y variables, and then just hit enter twice. It'll choose the first 2 options there. And then move down to calculate and hit enter. All right, that looks better. So again, Y equals mx plus b kind of format. Instead of an m, they're using an a. They have given us an a value of 4.148 and a b value of negative 117.676 if we would round. I do want to point out this. That is called your correlation coefficient. That is telling you how strong or weak the correlation is. So we are going to need that value. So what I'd like you to do is jot down in your notes. We have the equation y equals 4.148 x minus 117.676. We'll round to 3 decimals. And make a note that our R value is 0.915. Okay. Let's just go ahead and write that down here. Our correlation, our R value was 0.915. Anything that is really close to a 1 is really good. Anything really close to a negative 1 is also really good, just in a negative direction. So I would refer to this as a very strong positive correlation. Okay, let's go back up here. Remember that our x's and our y's from that table, our x's were the temperature, and our y values were was the cost of the electricity bill. Okay, so when we interpret our slope, that is our change in y, the change in the electricity bill for every change in x, the temperature. So we would interpret this to say, as the temperature increases by 1 degree, okay, so every 1 degree increase, our electric bill is going to increase by $4.15. Okay, so again, it's your y value, it's the cost of the electric bill divided by the x's, your temperature. Okay, remember slope is change in y over change in x. So we're looking at our y units, our dollars, and our temperature is degrees. So again, it's $4.15 per degree of change in temperature. Then it says predict the electricity bill for a month that has an average temp of 90 degrees. So go back to our equation. We said y equals 4.148. We know our x value. They want our temperature to be 90. I'm going to have to scroll back up here. Negative 117.676. All right, let's grab our calculator and figure out what that is. So go back to our calculator. I'm going to quit out of that screen. And let's go ahead and let our calculator figure this out. It was 4.148 times 90 minus 117.676. So our bill would be about $255.65. $255 and we'll say 64 cents if we round. Okay? So, quick reference about the correlation coefficient again. Our correlation coefficient is always going to be a number between -1 and 1, and it's strongest when it gets closest to that -1 or that +1. Again, a -1 would mean a perfect, all of your dots are right on a negative sloping line. A +1 means all of your dots land perfectly on a positive sloping line. Anything just inside of that, -0.9, +0.9, is still very strong. It just means you might have a stray dot somewhere in there. If the R value doesn't show up on your calculator, remember you have to turn the diagnostics on. So you're going to go to Catalog, scroll down to Diagnostics. Once you select Enter for that, it will still have that diagnostics on with a blinking cursor next to it, and you have to hit Enter a second time to actually turn it on. All right, let's try another example. It says the table below shows the median home prices in Florida. What is the equation of a line of best fit that models a relationship between time and home prices? Use the equation to predict the median home price in 2020. Start with x equaling 0, representing the year 1940. So again, a couple things about this. This is key. That statement right there. X being 0 represents 1940. We don't want to have to start our x-axis at 1940. We want to be able to start at 0. So we're basically going to adjust our x values, and 1940 is going to be represented by a 0. Okay, 1950 then would be 10 more than that, so we're going to use a 10. 1960 is 20 more than 1940, and we're going to keep going. So instead of putting our years in, we're actually going to be putting in those numbers 0, 10, 20, up to 60. Okay, so I'm going to go back, show you once again how we enter that into our calculator. We're going to go to Stat, Edit. Remember, we can arrow up to where it says List 1 and hit the clear key, and then either enter or just arrow down one. Let's go ahead and clear our second list so that we can create our new one. You always want to clear the numbers out rather than trying to type over them, because if you don't have as many numbers in your next question, then you'll have some values stuck in there that you can't get rid of. All right, putting our numbers in, we were going to use 0, 10, 20, 30, 40, 50, and 60. So we've adjusted those x values. And then our median home price, 23,100, 40,100. One too many zeros there. 58,100. 57,600. 83,300. Sorry, 89,300. 98,500. And 105,500. Okay, So again, make sure that your numbers are paired up. Now it says, what is our line of best fit? Interpret the slope and make a prediction. You'll notice that on our notes here, they've already graphed it for us, so we don't actually have to go through that graphing part of it. We're just going to go ahead and calculate that line of best fit. All right, so we are going to StatCalc. We want a linear regression number 4. Again, we've used list 1 and 2. And I'm going to move right down here to just calculate. We're not going to graph it on our calculator here. All right, so down at calculate, I hit enter, and there are my numbers. All right, so we want to put down our line of best fit. Y equals our A value, 1,411. Let's just round to 2 decimals for this one, 43, times our X plus our B value, 25,114.29. Anything 5 or higher, we would round up. Notice our R value is 0.98. Again, that is very close to 1, so I would say this is a very strong positive correlation. All right. Interpreting the slope. Remember, our X values were the number of years since 1940, and our Y values were the median home price. So our slope is our Y value, prices per year. Okay? Y over X. So we would say that for every year after, I'll say for every 1 year increase, the median home price for Florida increases by our slope here, $1,411.43. Okay, so each year from 1940 on, our median price is averaging an increase of $1,411. Now it says to predict the median price for 2020. You do have to be careful here. We said X equaling 0 stood for 1940. So X equaling what stands for 2020? How many years after 1940 is 2020? If you took 2020 minus 140, you'd get 80. So we're looking at an X value of 80. So that's what we're going to plug into our equation. So we're going to have our Y value, $1,411.43 times 80 years plus $25,114.29. When we add that all up, again, you can pause and use your calculator. You get a median home price of $138,028.69. All right, our next example. It says computer use and test scores. So this data is referring to the number of hours students spend online not doing schoolwork, just other things, and their test score. In other words, they're spending more time playing games on their computer versus studying for their test. So we want a line of best fit again. We're going to interpret our slope and make a prediction from it and look at our correlation. All right, so let's go back, Stat, Edit. Again, go up to the list name and hit clear and then arrow down or hit enter. Up to the list name, clear, arrow down or hit enter. All right, let's put our numbers in. Our x values are 0, 0, 1, 1. 1.5, 1.75, 2, 2, 3, 4, 4.5, and 5. Okay, so we've got our x's in there. Our y values: 100, 94, 98, 88, 92, 89, 75, 70, 78, 72, 57, and 60. Okay. I'm going to briefly on this one go through what our graph would look like, since I didn't give you a picture of the graph in your notes packet. I want to review how we can actually see the scatter plot. So we're going to go to y equals. Sorry, we're going to clear this one out. I don't want my old equation from that first example in there. Our stat plot is still set. We can do second stat plot if you're not sure. Go to the first one, it is turned on. We have our scatter plot selected for our picture. We're using list 1 and 2. And again, I've chosen the little squares for the marks. We can do a zoom 9, and it will take us to those dots. So just based on that picture alone, I would say I know I have a negative correlation because my dots are moving downward. It's not super strong, but I can definitely see a line going through there. I can do a pretty good prediction. So it's not going to be up to the 0.98 that our last one was, but it still should be fairly strong, but in a negative direction. All right, to calculate our line, we're going to do stat, over to calculate, choose number 4. I'm going to go through this store process because I want you to see what that does. If we do vars over to y variables, enter, enter, and now calculate. Okay, so let's jot down our equation before we move past that. Our line of best fit, y equals negative 7.91 times x plus our b value, 98.05. Let's jot down that our correlation coefficient, our R value, is negative 0.904. Okay, I do want to go back to our calculator for 1 second. If I hit graph now, you'll see that the line that I created, because I stored it in my calculator, is showing up on my graph. And you can kind of see how those dots match that line. If I go to y equals, you can see that they've typed in that whole big long decimal equation line for me. Okay? All right. So what does slope mean in this case? If we look at our x and y values, y is our test score, and x is the number of hours they spend online. Because our slope is negative, negative 7.91, it's telling us that for every additional hour spent online, and again, it's a little different this year. You're doing a lot of schoolwork online. Here they're referring to playing games, doing things online other than schoolwork. Okay, so for every additional hour that we spend online playing games, our test score will go down, because it's a negative slope, will go down about 8 points. Negative 7.91 to be exact. So Using that equation now to predict, if we spend 6 hours playing games instead of studying for our math test, what would our score probably be? So negative 7.91 times 6 plus 98.05. Grab your calculators, type that in. We get a y value of 50.59. So not a passing score if you don't spend time studying. Again, because our correlation here is a negative value, we would say it's a negative correlation. Because it's close to -1, we're going to say it's strong. So strong negative correlation. If you had gotten something like R equals, say, 0.6, I would say that's a pretty weak positive. A negative 0.6 would be a pretty weak negative correlation. All right. What I would suggest you do is pause the video and try this one on your own, and then turn the video back on and check your work. In this example, we're looking at the cost of 2% milk. Notice over here that it says our X being 0 would stand for 1998. So this would be times 0. 2000 is 2 years beyond that. And we're going up by 2-year increments. So our X values really should be 0, 2, 4, 6, 8, 10. All right, stat, edit, clear our lists. And we're going to put in 0, 2, 4, 6, 8, and 10. Our Y values, 2.57, 2.83, 2.93, another 2.93, 310, and 3.71. All right. Go to Stat, Calculate, number 4. Arrow down to Calculate, and there is our line of best fit. So we should be having our equation y equals 0.093x plus our b value 2.55 if we rounded. Interpreting our slope, again, our x's would be increasing by each year, and our y values would be the cost of the milk. So for every year, for every additional year, after, where did we start? 1998. For every year after 1998, the price of milk is increasing by 0.093. It's 0.093, so about 9 cents each year. How much would we expect to pay for a gallon of milk in the year 2025? So going back to our equation, now for x, we have to figure out what is our x value in 2025. We were told that 1998 is being used as x equals 0. So let's subtract 1998 from this, and we're looking at 27 years later. So we're actually going to put a 27 in here for our x value. Again, using your calculator, you should get that a gallon of milk in 2025 would cost $5.06 if the same pattern continued as it was from 1998 up to 2008. Our correlation coefficient was about 0.91 again. So again, a very strong positive correlation. All right. Thank you for your time.